Hi guys, welcome to week 3 of medical math. For those of you guys that are in my Monday morning class, we are going to be covering Unit 4 today in your books. And for those of you guys that are in my Tuesday morning class, we are covering the same subject material, but we are in the first part we're going to cover is in chapter 3, but when we get to the conversions part of today, we're also going to take a look at chapter 6. But they kind of go hand in hand. The things that we learned about in chapter 3 are the methods that we're going to use in chapter 6. So that's when we get to the conversions, and I'll explain that a little bit further. Hopefully your all's substitute passed out to you guys an equivalent sheet. That equivalent sheet will tell you guys what we're gonna need to know when we get to the conversion section for today. So what we're gonna look at today, the first thing I want to show you guys, we're gonna talk about ratios and proportions first. A ratio, what that is, very, very similar to what we learned about in fractions. As we talked about fractions last week, remember a fraction shows us one number written on top of another number. And a fraction represents a part, so the part being on top, to a total relationship. So in the fraction 3/4 that I have here on the screen, that shows that I have 3 out of 4 something. So if maybe I'm referring to all the students in my classroom, if out of every 4 students, if 3 of them are female, then that means 3/4 of the class are female. A ratio, we can actually, and we'll learn about this next week, but a fraction can actually be converted to a ratio. This fraction 3/4 can actually be converted to the ratio 3:4. So when we talk about conversions of fractions to ratios next week, you'll see they're actually very, very easy. And they're one and the same. They can be used, we can use one in place of the other. But as far as why we choose to use a ratio instead of a fraction, a ratio represents a comparison relationship. That we use the ratio 3:4 if I were saying maybe that for every 3 students in the classroom, or I'm sorry, for every 3 females in the classroom, there are 4 boys. So in the first example, we're saying 3 out of every 4. So that's why we use the fraction 3/4. So for every 4 students, 3 of them are girls. But in the ratio relationship, we're saying there are 3 girls to every 4 boys. So I'm looking at a total of 7 students in this example. So that's why we choose to use one in place of the other. But today, what we're looking at is actually they can be looked at very, very similarly, and we can actually interchange them quite often. When we see ratios, we can use fractions instead, and I'll show you exactly what I mean by that. In fact, they can also be reduced the same way we reduce fractions. If I have the ratio, let's say, that is a gigantic marker. I meant to hit the pen. So sorry. If I have the ratio, let's say 10:12, we know that if this were the fraction 10/12, that we would say, hey, both 10 and 12 can be divided by 2, so we would reduce that to 5/6 if that was a fraction. Well, and the ratio can actually be reduced the exact same way. Since 10:12, if we're comparing, say, again, 10 girls to every 12 boys, it actually makes more sense to reduce that and say that we have 5 girls to every 6 boys in the classroom. So they're reduced the exact same way. The difference is in terms of an improper ratio, where the number in front is the bigger number. Remember, in fractions, just as kind of a little side note over here, in fractions, the improper ratio, or the improper fraction 12/10 would have to be reduced. We would have to say, 10 goes into 12 one time with a remainder of 2. 10 stays our denominator, so that reduces to 1 1/5. Now, we don't do that here. One difference between our ratios and our fractions is that it is possible to have an improper ratio. Instead, we just do the same thing we did over here on the left side of the screen with our 10:12. Instead, we're just going to divide them both by the same thing, since we can divide them both by the same thing, we'll do so. Instead, in this comparison relationship, there just happens to be more girls than there are boys. Instead, if there are 12 girls to every 10 boys, it just makes more sense to reduce that and say that there are 6 girls to every 5 boys instead. So we would just treat it the exact same way, no matter which number is in the front, if it's the bigger number or the smaller number. Another thing that we'll take a look at in this section here when we're looking at ratios, the difference is what we want to see is that a ratio must always be a comparison of 2 whole numbers. For instance, let's say I have the ratio, let's say 20 to 1/4. What the heck does that mean? In this particular example, I'm showing that the comparison that we're looking at here is, say if I'm comparing, I like to use the analogy students to teachers. If I have 20 students to every 1/4 of a teacher at ATA, per se, that doesn't make any sense. We don't know what 1/4 of a teacher is. It would make much more sense to get this to where they're both whole numbers, and then we can better understand what this ratio is telling us. And how we do that, whenever we have a ratio that includes a fraction in our ratio, all we're going to do is we're simply just going to divide these two numbers. By dividing these two numbers, it would just be a faster way to go ahead and get these to where they're 2 whole numbers. Because what's going to happen at the end of this problem, since as you can see here, we're dividing fractions, what's going to happen at the end of this problem, my answer is going to be a fraction. One number on top of another. And as I showed you guys in the example earlier, fractions and ratios are truly just the exact same thing. Whatever we get, all we have to do is just write it side by side, separated by a colon instead of a line. Remember earlier I showed you guys the fraction 3/4 is the same thing as 3 to 4. And that's what's going to happen in this example, that when I divide these two fractions, my answer will be a fraction, and that will give me my answer. We can do that in any case. Just as kind of a little side note before I complete that problem right there, I want to show you guys, we could do that even if my numbers started out as whole numbers. If, say, for instance, I had the ratio 20 to 4 instead, they're both whole numbers. I could go ahead and just say, well, let's check this. What's 20 divided by 4? And you guys know 20 divided by 4 is 5. Well, what is that as a simplified ratio? What that actually means, 5 as a fraction is the same thing as 5 over 1, correct? We learned that last week with our fractions. So therefore, this simplified ratio would be 5 to 1. If say our comparison was, say, 20 students to every 4 teachers, then actually that makes more sense as 5 to 1. And we looked at it earlier, it was just easier, instead of having to divide my two numbers, whenever we start off with 2 whole numbers, it simply just makes more sense to say, 20 and 4, and that's, again, pretending like I haven't even done any of this. 20 and 4 can actually both be divided by the same thing. Like we said earlier with the 10 and 12, they can both be divided by 4. So therefore, I'm going to go ahead and do so. 20 divided by 4 is 5. 4 divided by 4 is 1. And that's where that simplified ratio comes in. Now, that didn't work earlier when we had the fractions 10, or the numbers 10 and 12, as I can't take 10 divided by 12 or 12 divided by 10 because it would give me a decimal. And so it was just easier to do what we just did just there and say, 10 and 12 can both be divided by the same thing. We divided them both by 2, and that gave us the reduced ratio of 5 to 6. But the purpose of me showing you that we could do that is to show you that when we divide the two numbers, it will give us a simplified answer. And so here, when we have a fraction, don't be alarmed by that I have a fraction as part of my ratio. All we need to do is just go ahead and divide the two numbers. And once we get our fraction answer, that's the same thing as our ratio. So let's go ahead and let's do that. So looking at the fractions here, 20 and 1/4, you guys are thinking, wait, 20 is not a fraction. But we can make it a fraction. Remember, in order to divide fractions, whenever we come across whole numbers, I simply just put it over 1, and now it's in that numerator-denominator form that I need it to be in. Remember, in division only, we apply that keep, change, flip rule. So 20 over 1 stays the same. That's my keep. My change is division into multiplication. And my flip 1 over 4 becomes 4 over 1. So now when I multiply straight across, 20 times 4 gives me 80. Down at the bottom, 1 times 1 we know is 1. So there's my fraction answer, but writing that as a ratio would just be writing it side by side instead. So in the fraction or in the ratio where we're comparing students to teachers, obviously this is not ATA, that's not the comparison there, but perhaps it may be a different school. If I said the ratio is 20 to 1/4, that doesn't make any sense since there's no such thing as 1/4 of a teacher. It makes more sense to see this, the simplified 80 to 1. Even though we've gone a little bit larger, that just happens to be the first. It just makes more sense to see that as two whole numbers instead, that there's 80 students to every one teacher. And that would work every single time you run across a ratio that contains a fraction in it. You just simply divide those two numbers. If you think about this, just to kind of think about it logically, if I said that I have, and just let me get rid of this real quickly. If I said that I had 20 students to every 1/4 of a teacher, I'm just kind of giving you guys a reason, or showing you guys why this works. What that means is if we were to double both of these, for instance, if I were to just, as long as I do the same thing to both numbers, if I multiplied them both by 2, whoops, get this out of here. If I were to multiply these both by 2, then that means I have 40 students to every half of a teacher. Still doesn't make any sense. And I'm just quickly multiplying these. You guys would see 1/4 times 2 is 1/2. If I multiply these again by 2, just to make sure I'm doing them both, I'm just really what I'm doing is I'm finding equivalent fractions, because remember, ratios and fractions are the same thing. 40 times 2 is 80. 1/2 times 2 is 1. So it just happens to be the first instance where we have a whole number in both cases, in both the front number and the back number. But instead of having to do that every single time, as it may not work out as easily, that just kind of helps us to see that a little bit better. If that didn't help, I apologize, but I just wanted to show you guys why this works out. But it can work, like I said, for any ratio that happens to contain a fraction. We can simplify it that way by just division. Even in the occurrence that both of my numbers in my ratio happen to be fractions, it would work out, or just to practice another one, if we had the fraction, let's say 6/7, or not the fraction, I'm sorry, the ratio 6/7 to 3. Again, another instance where we run into this comparison relationship and we're showing that there are 6/7 of a teacher to every 3 students at ATA. Once again, doesn't make any sense at all. So what we can do is we can just look at this as a division problem and go ahead and divide. Remembering how we divide fractions, we have to have them both in numerator-denominator form. So 6/7 is okay. 3, we just put that over 1. Now I keep change flip. 6/7 times 1/3. When I multiply straight across here, I get 6/21. So there's my answer, my ratio answer, 6/21. However, don't forget, we always want to reduce. And 6 and 21, you could either do that before you turned it into a ratio right here, or you could do it after you turned it into a ratio up here. Doesn't matter, as long as you're dividing both the numbers by the same thing, and we realize we can do that since 6 and 21 are both multiples of 3. I can divide them both by 3, and when I do so, 6 divided by 3 gives me 2, 21 divided by 3 gives me 7. So actually my simplified ratio is 2 to 7, which makes a whole lot more sense than 6/7 to 3. There's actually 2 teachers to every 7 students in this particular scenario. In some cases, you may actually run across the point where we have a decimal as part of our ratio, which can look kind of crazy. I know for those of you guys in my Monday morning class, you guys are looking at, on the first page where we're looking at simplifying ratios, I believe it's number 5. I'm sorry, I don't have my book in front of me right now. But the ratio looks something like this. And for those of you guys in my Tuesday morning class, you guys may not see anything like this. you may on a test, I don't know if you have any examples like this in your book right now though, but I'll show you guys, if you run across something like this, where I have 2/5 to 0.8, I'll just write 0.8, the correct way of writing that. Well, now that is super confusing. Now I have a fraction and a decimal, two completely different forms of numbers. What has to happen here is, just as we've been doing so far, we've just been dividing our numbers as fractions, because what I want at the end, I want my answer to be a fraction, since a fraction and a ratio are the same thing. So what I want to do here is I want to divide these two numbers as fractions, since I will get a fraction answer. 0.8 is not a fraction. It's a decimal. So what we're going to have to do is we're going to have to convert it to a fraction. And this is something that we haven't touched on just yet. We skipped over it at the beginning as I covered decimals in day 1 and fractions in day 2. We haven't had a chance to look at how to convert fractions and decimals. So I'm going to put this ratio off to the side for a second. We are going to actually come back to this one. And I want to show you guys just real quickly how to convert fractions to decimals. So we're going to look at, and I'll just abbreviate it, fractions to decimals. And then we're also going to take a look at how to convert decimals to fractions. Just real quickly, as this will help us as we go throughout the rest of the chapter as well. So just a quick side note real quick, and then we'll actually touch on this a little bit more next week when I come back. So looking at this first, really I'm going to look at fraction to decimal first, as that's a little bit easier. Anytime we have a fraction, so one that you guys are probably pretty familiar with, we know that 1/2, or in other words 1/2, is equivalent to the decimal 0.5. That's something that we probably already know. We've seen that many times. But what has happened here, an easy way to convert this, if you take that top number, 1, and divide it by the bottom number, 2. And you can do this in your calculator, guys. Remember, I encourage you guys using your calculators, and that's a much faster way to do it. If we take 1 divided by 2 in our calculator, and I'll do it by hand so you guys can see what is actually happening, you will see that your calculator would produce 0.5. And that is because if we did it by hand, remember long division, 2 does not go into 1. So if I add a decimal and a 0 and look at this as 10, 2 does go into 10 5 times. Since 5 times 2 is 10, I get 0 as my remainder. Don't forget to bring your decimal up in your problem. So that's, if I did it longhand, that's where the 0.5 comes from. We just take top divided by bottom, and every single time that will give you your decimal. And that works for every single fraction. If we had the fraction, say 3/4, another one you guys may be familiar with, all we have to do is take 3, look at this line right here as if it says divide, 3 divided by, now 4. You'll notice that in your calculator it spits out the decimal, 0.75. If maybe, just giving you guys a different one, we had the fraction, I don't know, let's say, oh, sorry, trying to erase this here real quickly. If we say had the fraction 1/8, 1, we'll give you the decimal 0, that's supposed to be a 0, sorry, 0.125. So that's just a real quick, easy way to convert your fractions into decimals. And one thing I'll also show you all too, don't be thrown off if you happen to have a number in front of your fraction. Right here we have 1/8, and that turned into the decimal 0.125. That was because there's nothing in front of my fraction, so that's where that 0 comes in. It's like we have 0 and 1/8, so therefore my decimal is 0.125. If I did have something in front of that fraction, say it was, let's say 3 and 1/8, then that 3 simply just becomes the number that goes in front of the decimal. So this would just convert to 3.125. That 3 that's in front will replace that 0 from your calculator. All you have to do is convert the 0.8 part of it. So given just another example, let's say we have, I don't know, let's say 6 2/5. 6 2/5. All I have to remember is 6 is my whole number, so 6 is going to stay the number in front of my decimal point. All I have to do is take 2 divided by 5, and you'll notice in your calculator that gives you 0.4. So this here, on the 6 2/5 would be 6.4. The 6 just stays the same there. So that's how we convert fractions to decimals. Now looking on the other side, decimal to fraction involves just a few more steps, but not many. All we need to do when we're converting a decimal into a fraction, I'm going to start with the one we began with over on the fraction to decimal side, 0.5. We know that that converts to the fraction 1/2, correct? What has to happen here is I want to take this decimal. The idea is to take this decimal, this 0.5, and turn it into a whole number. We did this day one when we were converting, when we were doing long division. We had that the outside number had to be a whole number, so we moved our decimal point as many times as we needed to get it to the end. Hope you guys remember doing that. That would change this into the number 5. What that tells us is, as far as where we're going with this, turning that decimal into the whole number 5 is going to give me my numerator of my fraction I'm trying to create. The movement of the decimal is going to be where that denominator comes from. But remember, and so a lot of you guys are thinking, oh, well, you moved it one time, so is the denominator 1? It's actually not. Remember, when you move a decimal place, remember place values are based on tens. So when you move an entire decimal place, you actually move by 10. So one decimal movement would be 10, whereas 2 decimal movements would be 100. 3 decimal movements would be 1,000, 4 would be 10,000, and so on. So another way to think about it is, remember, the number of times you move your decimal here is going to be the number of zeros you have in your denominator. Looking at this, you might be thinking, well, 5/10 is not 1/2. But it is. Because remember, what do we do with our fractions? We always must reduce our fractions. So 5 and 10, since they can both be divided by 5, we do so, and that's where that 1/2 comes in. So that's how we got that fraction from 0.5 to then 1/2. So doing another example then, let's say we have, just starting off with one that's 2 movements. Let's say I have the decimal 0.45. This time, I want to take that decimal point and move it as many times as I can to get it to the end. That will produce the whole number 45. So there's my numerator. The denominator, since I moved the decimal twice, I'm going to see 2 zeros in my denominator now. Remember, each movement is a movement by 10. So 2 movements means 2 zeros in that denominator. And then all we need to do is reduce it. 45 and 100, looking at that, I can see that they're both multiples of 5. So dividing them both by 5, 45 divided by 5 is 9. 100 divided by 5 is 20. So that gives me my reduced fraction. And you can always double check to make sure your reducing is correct by doing what we did over on the other side. Since over here, fraction to decimal is numerator divided by denominator. If you took numerator divided by denominator over here, you should produce the fraction. You should produce the decimal 0.45. And that just shows you that you did reduce your fraction correctly. Okay, and just taking a look at another one here. Let's say we have, hang on, let me get some of this out of the way here. I'm going to move all this out of the way. Okay, and just like we did over on the fraction to decimal side, whenever we have a number in front of our decimal, that will also match the number in front of my fraction. So if I had the decimal, say, just for practice purposes here, because we'll come back to this and focus more on this next week. If I had the decimal 6.25, you guys might be familiar with 0.25 as if this was 6 1/4, or $6.25. Then that's, and I already said what fraction that's going to turn into, 6 1/4 or 6 1/4. But where that's from is, again, 6 stays your whole number. You don't have to even worry about that. Instead, simply, you've already kind of put that in front of the the fraction there, just focus on that 0.25. And just as we did before, we simply just need to move our decimal all the way to the end to turn that into the whole number 25. Since I moved it twice, that's going to be the denominator 100. And 25 and 100, once you reduce that down, whether you're reducing it by 25, maybe you divide them both by 5, realize you can reduce again. Either way, that comes down to 6 1/4 when you get it down all the way. So that would be our reduced fraction. Again, we'll touch more on that a little bit later, but I wanted you guys to see how to do that for the purpose of reducing this ratio. So I'm going to go ahead and clear all of this out here so that we can see what that would be once we get back to that ratio, which was 2/5 to 0.8. Like I said, we want to go ahead and divide this to simplify this ratio, but we want to divide them as fractions, not as decimals. We want to divide them as fractions since we want our answer to be a fraction answer. So what we're going to do is we're going to take this 0.8 first, and we're going to go ahead and convert that to a fraction. 0.8 we know would be the fraction 8/10, again because I had to move that decimal all the way to the end here to get 8. Since I moved it once, that's where 10 comes in as my denominator. 8/10, we can divide both of these by 2, and when I do so, that gets us down to 4/5. So really what this ratio says, to better understand that and see that as fractions, this ratio says 2/5 to 4/5. So again, we reduce ratios that have fractions in them by division. So since they're both already in numerator denominator form, we're going to just keep change flip 2/5, and then so there's our keep, our change, and then here's our flip. 4/5 becomes 5/4. Multiplying this straight across, we get 10/20. So once I get this down here, wait, that doesn't seem right. Is this the same one? This might not be the same one that's in your book. Yeah, I don't think this is oh, I know. I think the one in your all's book is 0.8 to 2/5, isn't it? Either way, we just have the reversed of the one that's in your book. I apologize. But you guys still get the idea, is that we want to convert that to a decimal. Convert that decimal to a fraction. I'm sorry, I can't think or talk today. But we're doing all the same steps. This is all correct. But once we reduce that, we get that down to 1/2. So therefore, our reduced ratio, I don't have any room down here at the bottom of the screen, so I'll write it here in the center. Our reduced ratio would be 1 to 2. I'm sorry for those of you guys in my Monday class. I know that number 5 in your all's book is, I think it's reversed of that. I think we would reduce that down to 2 to 1, the one that you guys are looking at. But the one that we had on the screen here, absolutely, that would reduce down to 1 to 5, or 1 to 2 there. So that's how we would reduce those if we ever come across a ratio that happens to have both a fraction and a decimal in it. We simply just divide those, or even if they're both decimals, might be easier to just, which I don't know where you'll see that, but it might be easier to just convert them both into fractions and divide those fractions. I know we hate fractions, but we can get through this as we are just only using those for dividing. We're only going to divide these for the purpose of simplifying these ratios. So I hope that helps with what ratios look like, with the simplifying of ratios. I'm going to go ahead and stop this video here and just focus on those ratios in this one, and then the next video we'll focus on something else with our proportions.